Hi everyone. Today we're going to begin looking a little bit at what we call continental drift. Should you need to get a hold of me, my email address is on the screen. Just hit pause, copy it down, and send me a message. Let's jump right in. So, when we talk about continental drift, I really want to start with this idea. Like, this is a world map, and this is a very, very familiar looking map. This is a map that you would expect things to be where they are. We expect to see North America here, South America here, Africa, Europe and Asia, Australia, Antarctica. And then we have like the Pacific Ocean, Atlantic Ocean. This is the way that we expect to see things. And it's really easy to imagine that Earth just really doesn't change. But the reality is, when we studied weather and erosion, we know that over millions of years, mountains are pushed up and then they can be worn back down. You already know that many plants and animals, they live, they die, and entire species become extinct. And I think, at least to some degree, most of you understand that the continents under our feet even move. And so this is a world map of today, but the world has not always looked like this. There was a gentleman, and his name was Alfred Wegener. Alfred Wegener he first hypothesized that continents were moving. And I'll tell you, he looked at a map and he noticed that South America and Africa really seemed to fit together. He noticed that they were like pieces of a jigsaw puzzle, and he did not think it was a coincidence. And so Wegener, he developed an idea that he called continental drift. And his idea was that the continents had at one time been all together in a very large single mass of land. They weren't separated by oceans. There was a single land mass on Earth, a single continent that he called a supercontinent, and that since that continent, over time, that continent had broken up and the continents had moved to the places where they are today. And so that was his idea, was that the continents had all been together into a large supercontinent, then they slowly drifted apart to their current positions. Now, and he based this really to begin with just off that jigsaw fit between South America and Africa. Of course, scientists are skeptics, and other scientists absolutely did not believe his idea because he couldn't explain what was moving the continents. Why would the continents be moving? And he had no idea. So Wegener did. He decided that he was going to go find this evidence that scientists were looking for. And so, he named his continent, his supercontinent, he called it Pangaea. And Pangaea, he thought Pangaea existed about 300 million years ago, based on looking at some fossils and rocks at that time. So, what was his evidence? So, as he began to travel the globe, Alfred Wegener began to travel the globe, and he began to look for more than just the jigsaw fit of South America and Africa. And the first thing he started to do was he started looking at fossils. And what he discovered relatively quickly, as he began looking at these fossils that had been discovered on each of the continents, is that there were these bands of identical fossils that were found on all the different continents. And those bands really seemed to match the way the continents would fit together. And so, he knew that this was a huge piece of evidence because it would be highly unlikely that so this is a fern, a particular type of fern. He knew that it was highly unlikely that this fern, which is a tropical plant, first off, would be found in Antarctica, or that it would be found across all of these continents. The same thing for some of these early reptiles. He found them across multiple continents. He knew that these were, this is something called a Lystrosaurus. He knew that Lystrosauruses could not swim based on its body features. And so this was really strong evidence that continents had been together as one. He also was looking at the types of rock that the fossils were in. And what he found is there were also bands of types of rock that seemed to be identical on the continents that would match the climates for that they should have formed in. And these bands of rocks also would have been really difficult to understand if the continents had never been joined together. So sadly, Wegener was never accepted. His idea was never accepted. even though Wegener was right, it is true that about 330 million years ago, Pangaea formed, and then later on, after some million years, it actually split back apart, and the continents had moved back apart to their current locations, and they've stayed separate. So Wegener was right, but he could never really prove it. The scientists would never accept they would never really accept this evidence because he couldn't give a mechanism that would be moving those continents. So I want to have you look at sort of the strongest bit of evidence I think that Wegener had, even though I don't know that it was sort of what he relied on. So you may remember when you studied climate last year that there are different climate zones. You have a polar zone. Polar zones are near the poles, and you're going to find that it's always winter in these areas, right? Because it's near the poles. It's going to be cold and very dry there. Sort of down below or away from each pole, we have what are called temperate zones, where we live in a temperate zone. We have hot summers and cold winters. And then right near the equator here, which is like that line that dissects the Earth or bisects the Earth, it's going to be always summerish here. It's going to be hot and wet. So this was a big bit of evidence. Now we know that one of the continents today is Antarctica. So Antarctica today is covered by ice sheets that are miles thick. Average temperature here is like minus 50 degrees or something. It's ridiculously cold. But when Wegener was looking at fossils, the fossils that Wegener was finding, he was finding fossils that he would find in a tropical rainforest. He was finding things like ferns, and he was finding reptiles, which are cold-blooded. So really, the strongest bit of evidence, I think, for Pangaea that he had was this idea that Antarctica must at some point have been closer to the equator and that its climate was much different. Okay, so Antarctica, where it is now, there is no way a rainforest could form if Antarctica had not moved, right? But we have this fossil evidence to show us. So really, at this point, it is foregone. Science no longer questions whether or not the continents are moving. We can look at the evidence, and we can look at the bands of fossils, and those absolutely add to what we know. But the reality is now we have satellites in space. We have global positioning satellites, or GPS satellites, that we can use to actually track the moment or the movement of the continents. So we know, we not only know that they are moving, we also know how fast they're moving. We know what direction they're moving in. And so, Wegener was right. He did not have the luxury of GPS during his time, but this idea that the continents are moving turned out to be a really strong prediction. And his idea of continental drift, though he could not tell us why, turns out to be one of the most important ideas in science today. So before I leave you for the day, I just want to point out I usually have questions say about Pangaea and was it the only supercontinent? Some of you may have heard that there were others, and it is true that Pangaea was not the only supercontinent in Earth's history. There have been several others. This is a list of supercontinents, and this gives you the approximate time that scientists believe that these continents were together, where all the land masses were together, and this is their name. I do want to at least take one moment to look at this last one. This is called Pangaea Ultima. And so notice that this says 250 million years into the future. So we know the continents are still moving. We know the direction they're moving in, and we know their speed. So we can make some predictions. And so, about 250 million years from now, that world map is not going to look the same anymore. We are expecting another supercontinent to form in about 250 million years. They've already named it Pangaea Ultima. They've already begun looking at how the biomes would be different on it. And so keep in mind, Pangaea was not the only supercontinent. It was just the last supercontinent. And it is not going to be the last one ever. We fully expect that Earth is going to bring those continents back together again. All right, guys, I hope you have a great day, and I'll see you soon.